Is this your greatest fear, needing to clean up a spill and finding no paper towel left?
Today we're going to test 2 brands of paper towel. Is On Brand really worth it? Let's find out. Okay, since we're doing a related rates problem, first we need to find the volume of the shape we're working with. It's working with a cylinder. Our formula is pi r squared times h. And our needed rules to solve this problem are the power rule and the product rule. Using these rules, we will find the derivative in respect to time. Okay, to find the derivative of the volume, we're going to use the product rule and put it in respect to time. First, we're going to start with our f of x, pi r squared, and our g prime of x, which is 1. And then we're going to multiply that by dh over dt, which puts it in respect to time. And then we're going to add our f prime of x, which is 2 pi r, and then multiply that by our dr of dt, which puts this in respect to time, and then multiply it by g of x, which is h. We're going to get this answer.
We'll start our study with Bounty. Margaret and her cat both make a spill of equal volume and use Bounty on the first spill. It takes 2 paper towels to clean the whole spill. For the second spill, we use Off-Brand, which takes 4 paper towels. Margaret makes another spill and tries to blame her cat for this one, even though it's her fault. This time, she gives Off-Brand a second chance and takes 4 paper towels. Oh my.
Okay, now we're going to plug our values into our derivative. First, we have our radius and height, which are taken prior to our experiment. Our radius is 3 inches, and our height is 11 inches. And we're going to plug those into our formula, here and here, this here, here. And next we have our dr over dt, which is our change in radius in respect to time, which is negative 1/8 inch, because it used 2 paper towels to clean up the spill. And next we have our dh over dt, which is our change in height in respect to time, which is 0, because the height does not change throughout the experiment. And then we're going to plug it all in here, and then we're going to put it in the calculator and get this answer. Is it supposed to be square? And now we're going to do the same thing with our Off-Brand paper towel. It has the same radius and height, so we plug those into the same spots in our formula, but the dr over dt has changed because we used 4 paper towels, so now it is negative 1/4 inch. We plug this in over here, and the dh over dt is still the same because the height did not change throughout the experiment. We're going to plug that in, and we're going to put it in our calculator, and we're going to get this answer. So what do these results mean? Well, our dv over dt represents our change in volume with respect to time. For Bounty, we had negative 25.92 inches per hour, which is how much our volume decreased per hour. And for Off-Brand, we had negative 51.84 inches per hour. So, who wins? Clearly, since Bounty decreases at a much smaller rate, Bounty wins. Yes. Find the derivative.
Sydney, I need you to explain this math to me.